So welcome to the class. So in this class we are going to discuss about the AC servo motor, and we are just going to derive the transfer function. Okay, transfer function of two-phase AC servo motor. Transfer function of two-phase AC servo motor. Two-phase AC servo motor. All right. In which we are going to relate the angular shift in the shaft. Angular shift in the shaft means theta m, and the input voltage control, input control voltage, that is VC. Okay, so we are going to derive the transfer function using this input and the output. All right, so let's move further. Now the two-phase AC servo motor uh, is simply a two-phase induction motor. All right, two-phase induction motor, in which you can see that this is one winding and this is the second winding, which is the reference winding. Okay, the control voltage VCT, here you can see the control voltage VCT is applied to control the control winding. This is simply referred as control winding. All right, and a fixed voltage having a phase difference of 90 degree with respect to the control winding voltage, is applied to the reference winding. Okay, यहाँ पर reference winding भी हम उस पर apply करेंगे, because you know that single phase induction motor is not a self starting motor. We need an auxiliary winding or the reference winding. This is that winding which we need, and both these windings are 90 degree apart. Okay, when your motor gets started, we remove this reference winding. Okay, so these windings are 90 degree apart. Okay, so the control voltage, this control voltage VCT results in the development of the motor torque. The torque which is being developed at the motor, that is a motor torque. This control voltage helps to develop the motor torque Tm, and the simple relationship between the Tm and the omega, and that is simply the speed and or the torque speed characteristics of the motor is shown over here in this. The characteristics is shown over here. Okay, you can see that here is a control voltage. Control voltage VC is the maximum, VC1 is less than that, and VC2 is less than that. Okay, तो जब VC जब maximum होगा, so you know that this will be T0, और जब आप इससे कम करते जाएंगे तो likewise your torque will going to decrease. Okay, and simply this is the relationship or the characteristics of the torque speed characteristics simply of the two-phase AC servo motor. All right, now just keep in mind these characteristics under this two-phase AC servo motor diagram. Let's move further. Here in the diagram you can see that Jm over here, which is shown, it is simply the moment of inertia of the at the rotor, okay, of the motor, at the shaft of the motor, and Fm is simply your viscous friction. Okay, it is simply the viscous friction, and theta m is simply your angular shift. Okay, theta m is your angular shift, and omega m, you know that omega m is your angular velocity. Okay, so let's move further and derive the relationship of the transfer function. Now from the torque speed characteristics, the dynamic equation relating the motor torque, that is Tm, and the speed is simply Tm, that is the motor torque, should be equals to m into omega m plus k into Vc. Now what is this? Let us look further. Now considering the characteristics, you can see that from in this equation, m is simply the slope. Okay, so slope you can calculate it very easily, that m is simply the slope of the torque speed characteristics, which is m is equals to minus T naught upon omega naught. All right, T naught upon omega naught. So this should be the slope, which is expressed in Newton meter. Okay, Newton meter per radian per second. Okay, it should be negative. As you can see, the slope is negative. Okay, so you have to determine the m from here. And how k will be determined? K can be determined very easily when your speed, this speed is 0. The speed is 0. You know that when speed is 0, torque is simply T naught over here. Okay, so when you put omega m is equals to 0, omega m is equals to 0, when speed is 0, okay, Tm will be equals to T naught. It is simply called as stalling torque. What is stalling torque? Stalling torque is simply the torque when your motor stops running. As you can see from the characteristic that when your speed is becoming 0, it is giving Tm is equals to T naught. So okay, it is called stalling torque when your speed becomes 0. Okay, so in the above equation, in this equation, if you put this, then you should get T naught will be equals to K Vc, and it will give you the value of the K. So K will be equals to T naught divided by Vc. Okay, it is expressed in Newton meter per volt. All right, and as we all know that since we know that omega m is angular speed, this is simply equals to what? D theta m over dt. Okay, differentiation of the angular shift. Okay, so the torque equation given over here, when you put omega m is equals to this Tm will become that if you put omega m is equals to d theta m over dt plus kvc. So from here we will calculate the transfer function which we have mentioned at the starting. So the related dynamic equations are simply what? The corresponding Laplace transformed equations. Equations are okay. So first is Tm, which is equals to m d theta m over dt plus kvc. Okay, so let's write down in the Laplace transform Tm as, this will give a single derivative, Sm theta m s plus kvc s. Okay, so this is the Laplace transform of this equation. And as you all know that the relation between when you have studied about the mechanical system, in that you have derived the equation which is relating the torque versus the angular shift. That equation is what? Since we have a moment of inertia Jm, moment of inertia, double derivative of angular shift plus friction and d theta m over dt. Okay, so this will give you Tm as Laplace transform of this. Since this is a double derivative, so the Laplace transform of this should be s square Jm theta ms plus s, since this is a single derivative, s fm theta ms. So we have got these two equations. Now from these two equations we are just going to draw the block diagram. Okay, from that block diagram we are going to derive the transfer function. So just remember these two equations, and now I will draw the block diagram by using the above two equations. Okay, so from the above two equations you can see that this is the block diagram of the two-phase AC servo motor which is relating your theta ms, that is the angular shift, with the vcs, which is the input voltage. All right. So in this, from the above equation, this equation, you can see that kvc, okay, kvc is given over here. K vcs we have given input multiplied by this k, okay, we have got kvcs over here. Okay, so sorry, kvcs over here. Okay, now you can see that s square jm plus s square jm is over here plus sfm over here. So अब यहाँ से अगर आप थीटा एम एस और थीटा एम एस अगर यहाँ से कॉमन निकालेंगे तो यू विल गेट एस स्क्वायर जे एम प्लस एस एफ एम. ओके, सो थीटा एम अपॉन टी एम एस, दैट इज द आउटपुट अपॉन द इनपुट. Okay, so from this equation you get what? You simply get output upon input is equals to this one. Okay, we are getting this. Okay, and this equation is this sm into theta ms. Okay, so theta ms we have got sm as feedback word over here. तो यहाँ से जब ये sm आपका यहाँ जाएगा और फिर यहाँ पर आपका समीशन पर we are getting sm from there and kvc from here. तो kvc and sm, kvc from here we are getting this, sm from here we are getting this. We have done the summation over here and we are getting this equation equals to tms. Okay, we are getting tms from here. This is how we are getting the tms by using this feedback loop. Okay, so just simplifying this, we have simplified this. So this block diagram is reduced in this one. Okay, so we have got k over s sjm plus fm minus m. Okay, तो ये simply आपका transfer, that is giving the transfer function. So let us write down the equation, that is simply theta ms upon vcs is equals to what? Is equals to k upon s in bracket sjm plus fm minus m. Now you can further reduce this equation. How you reduce? K upon fm minus m, okay, s upon 1 plus sjm upon fm minus m. We have just reshuffle this equation. Now what we got? km upon s 1 plus stm, where km and tm is what? Km and tm is simply k upon fm minus m, which is what? This is your motor gain constant. All right, and here you can see that tm is what? Tm is simply jm upon fm minus m. Okay, this is termed as motor time constant. Okay, so this is simply the transfer function. This is simply the transfer function of what you can say, motor shift. Okay, angular shift to the input, which is your input voltage vcs, and we are getting this at the as a transfer function. Okay, so this is up to here in the AC servo motor. Thanks a lot.